Let's look at the tabular method for integration by parts. The tabular method is useful when you're integrating a function where you have a polynomial and it's either multiplied by a sine, a cosine, or an e to the x, or e to the constant times x. The idea behind this is polynomials, when you take the derivative repeatedly, eventually you get to 0. So here's the method. Rather than writing out directions for it, I think it's better just to see an example. So what you do is you write the polynomial here, and then you write the other part here next to it. And we're going to do 2 columns. Now when we go down this column, we're going to take the derivative. When we go down this column, we're going to integrate. And since we've got a polynomial, let's see, x squared, that gives us 2x. Derivative of that is 2. Derivative of that is 0. When we do the integration over here, you integrate cosine, you get positive sine. And we have to divide by 2. When you integrate sine, you get negative cosine. And you have to divide by 2, so we get a fourth. And when you integrate cosine, you get sine. And it doesn't change from positive to negative. So this stays negative, and we have to divide by 2 again, so we get 1/8. So we've got these 2 columns here. And then what you do is you draw lines, slanted lines like this. And then you alternate pluses and minuses on them, starting with a plus. And now we can just read off of this, and this will tell us what our integral is. So the first term of our integral is going to be this. Maybe it's worth actually circling that where it will stay. So our integral is going to be 1/2 x squared sine 2x. Then next term is going to be made up of this. So that's going to be plus 2 1/4 gives you 1/2 x cosine 2x. And then the last one down here gives us, let's see, 2 times negative 1/8. That gives me minus a fourth. Run out of space, I'll write it down under here. Minus 1/4 sine 2x plus c. So that's, I don't like breaking things up over lines like that, but that's the method you use to do tabular. Now the reason this works is if you go through and you compare this to integration by parts, this is like our u's and dv's, and the reason for the alternating sign here is because of the minus between uv minus integral v du. So that's the general technique. Let's see. I've got 2 examples here. Let's do one example right now. So to do this guy, I'm gonna erase this above. To do this example, we've got x squared plus x, then e to the half x. All right. So going down this way, we're going to take the derivatives. We get 2x plus 1, then 2, and then 0. And over here, when we integrate, we get e to the half x. But we got to divide by a half, so let's multiply by 2. You get e to the half x, multiply by 2, e to the half x, multiply by 2. And in the interest of space, I'm going to slide this over to the side. Plus, minus, plus, and we'll just read it off of here. We get x squared plus x times 2 e to the half x minus 2x plus 1 times 4e to the half x, and then plus 16 e to the half x plus c. Squiggly barrier there. And let's see, can we do anything with this? Yeah, we can factor out e to the half x. I actually want to do that. We can factor out e to the 1/2 x. And we're left with, let's see, from this term, we're left with 2x squared plus 2x. Then from this term here, we get minus 8x minus 4. Then from here, we get plus 16. So e to the 1/2 x times, let's see, 2x squared minus 6x plus 12. I guess we could factor a 2 out of that now if we wanted to, but I'm out of space, so I'm not going to do it. So anyway, that's another example with tabular integration by parts.